Good morning. We are going to do section 3.1, lines and angles. So if you look in your book, it's going to be pages 129 through 134 if you need it as a reference. But you're going to have to take notes, so make sure you write the title, 3.1, lines and angles, and today's date, which is the date for today. It's November 18th. Okay, so let's go ahead and get started. We're going to do the entire chapter or the entire section today. So our first objective is going to be identifying relationships between lines. So we're going to look at some lines in space, and we are going to identify those relationships, and then we're going to identify some angles formed by a transversal, and I'll explain what a transversal is to you in a few minutes. So let's go ahead and look at the first definition. Now, our first definition is about parallel lines. Now, a parallel line means that they are not coplanar, they don't share the same plane, and they never intersect. They do share the same plane, they never intersect. So basically, a parallel line is going to be a line that is drawn. Remember, a line has arrows on both ends. So a parallel line to this line would be right next to it because they never intersect, okay? So those are parallel lines. And then we're going to identify a parallel line. Let's say this is line AB, and this is line CD. We would write that as line AB is parallel to line CD. Okay? Well, there's another way to write it. Instead of writing all of these words in between, you're going to write AB, line AB, is parallel with those two lines straight up and down, CD, line CD, okay? So there's two ways to write that for our parallel lines. All right, so we're done with parallel lines. And now let's move on to skew lines. So skew lines do not intersect and are not coplanar at all, okay? So basically they are just lines. Let's say one is here, and then one is over here. They don't intersect, they're not on the same plane, they are just far apart. So then this would be AB, and this would be CD. And we'll notice that when we start looking at a figure, what those skew lines are, okay? And then the third one are two planes that do not intersect, parallel planes. They do not intersect. So basically a parallel plane is, let's say we'll draw a plane here. Remember, plane is this two-dimensional figure. And we're going to call this plane U. Okay. And then we're going to have another plane. They're parallel, so they're the same size. They're right next to each other. The only difference is they don't intersect, okay? And we're going to call this plane W. All right. And then the way we would list this is plane U is parallel to plane W. Okay? So we're just talking about parallel lines here. And there's one more word I want us to discuss because we didn't really get a chance to do it earlier. And I'm going to write it at the top. And it is called perpendicular lines. Perpendicular. Now I'm going back to see which section we missed that in. It was, I forgot the page number. Because it was before section 2.4. And that's where we started in chapter 2. Okay, here we go, page 79. There we go. So basically a perpendicular line, it's two lines that intersect to form a right angle, okay? So perpendicular lines are two lines that intersect to form a right angle. And I'm gonna draw that for you. So basically we have a line straight up and down. And if we wanna draw a line that's perpendicular to that, it's going to intersect to form a right angle. So we would draw a line that's straight across. And the symbol as a right angle would be this little box in the corner. So that means that's a right angle and a perfect right angle. So we would have line, let's call that line N, and then we'll call this line M. And we could say here that line N is perpendicular to line M. Okay, so that perpendicular is this upside down T is how it's represented. So instead of the parallel lines between, we would write this upside down T between, okay? So that's essentially perpendicular lines, so make sure you get that as well. And if you need a reference to it, it's gonna be on page 79. All right, so let's go ahead and go back to this section and look at our first example. Here, we're gonna identify some relationships in space. So we're gonna look at this cube and look at each different line separately. Okay, so if we look at this cube, we have a lot of points. So A, B, C, D up here, and then we have E, F, and then G, and then H point down here. So basically, this would make the line AB, okay? And then this from E to H would make the line EH, okay? And then this from A to E would make a line AE. So there's several lines on this space here. So let's look at each segment in the diagram separately, just like I listed here. And we're going to identify what would fit with the description. So the first one I want us to look at is what line is parallel to AB and contains D. So I'm looking here, parallel to AB. So here's our AB. I've already drawn the line segment here. So parallel to AB, meaning that it is on the same plane, but it never intersects. So if we were to look at that, we can identify a few of them that are on the same plane or in the same space, but they never intersect. So the first one is right next to it would be this. So CD. So this line segment here would be listed as parallel to AB. So let's go ahead and write that next to it. So we have CD would work. Do you identify another line that would be parallel and in the same space? Well, another one is going to be EH. EH is also parallel to AB. So I can write EH. And then the last that's parallel is going to be GH. And we know that they're parallel because this makes a perfect cube. So they're perfectly parallel. So then it would be, the last one would be GH. Now, they give us two parts to this. It says it's parallel to AB, so we identified all three of the lines that are parallel to AB. And now we need to say it contains D. So which one of these line segments would contain D? Well, it's this one, the only one with a D in it. So CD. So this would be our answer. So line segment CD is parallel to AB, and that's the only one that would fit that description. On B, it says, which one is perpendicular to AB? Perpendicular. Now remember, perpendicular forms a right angle at an intersection. So let's go ahead and look at which ones would be contained for AB. Which is perpendicular to AB here? So there's actually a few. So I'm going to try to get another marker. They're all red. Here's a green one. All right, so perpendicular to AB is going to be, so let's, ooh, that's green. That doesn't look green, huh? Let's use orange. All right, orange it is. So let's use orange here. Perpendicular to AB. So we're using AB here. So what lines are perpendicular that would form a right angle? So if we looked at this, our first one that we can see very easily is this line here, okay? The reason it's this line, because if I were to extend this all the way through, it is intersecting, and this actually would make a right angle. So the first one is going to be AE. AE would be the line AE, okay? And then the next one that we see, that's right next to it, but on the other side, is going to be BF, so this one here. So we look at this one, if it were to extend, this would also make a right angle, and that would be BF. And there are more. So here, it's coming out the other way, but AE would also make a right angle. I'm sorry, AD. So AD, and then the last one is going to be over here. If that were to extend out, it would also make a right angle. So BC. But the other question they're asking is, not only is it perpendicular, but does it contain D? So this one here, and there's only one that contains D, and the only one that contains D will be line AD. So this line segment, this line segment right here contains D and is perpendicular to line AB. All right, let's go ahead and look at the skew lines. So if we looked at those, I have a brown marker. Remember, a skew line is not coplanar and does not intersect. So on a skew line, it does not intersect and it is not coplanar. So we have AB here, the same line, and let's find the lines that do not intersect with it and do not lie on the same plane. And remember, to lie on the same plane, it would have to be this plane here or this plane here. All right, so the only ones that would do that is if we looked at D, so D and G, DG, which is this line here. So DG would be 1. I'm going to write it under here. So under C, it would be DG. The other one that's not perpendicular or parallel or on the same plane would be our GH here. DH, I'm sorry. DH. And the last one that contains D would be DE here. This diagonal line, so DE as well. They all pass through D and they are all skew to line AB. Okay, so there are 3 answers to that one. And then on D, the last one, name the plane or the planes that contain D and appear to be parallel to A, B, E. So let's look at A, B, E here. ABE is this plane here. So I know I'm about to draw over it. This plane right here. Okay, that is our ABE. We're going to name the planes that contain D and appear to be parallel. So remember, parallel is right next to each other. So there's only one that would be parallel to ABE, and that would be DCH. So the parallel plane, which is 2-dimensional, would be this plane here. And as you know, they're parallel to one another, and it is a plane, so DCH. So we're going to call that one. So our answer here would be DCH on that plane, okay? So we're looking at relationships in space. So we need to know the terms parallel, perpendicular, skew, and the difference between a line such as AB and the plane ABE, okay? Those are the solutions. I forgot to put those in there. Parallel postulate. Okay, we're moving on. So we're going to look at just the basic parallel postulate. Remember, a postulate is just a rule that does not need to be proven. So this is the rule, and we're just going to list it out because I've already drawn the diagram here. But it says if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. And I give you these here, okay? But I'm going to actually draw it separate so you can see what order I'm talking about it in. Okay, so let's just say I have a line. Ignore this for right now. I have a straight line, and I should be using my straight edge when I do this, but I'm not. I'm sorry. So I have a line, okay? And the only reason they draw